Hello everyone, we are Group 1 of Division E. These are our group members, and our topic for the presentation is complete instruction execution. So what is complete instruction execution? A complete instruction execution is a process that involves a full execution of an instruction in a computer program. This means all the necessary steps that are involved in executing an instruction and that are carried out before moving on to the next instruction. So the benefits of using instruction execution cycle is it provides you program efficiency, it provides reduced errors and a better system resource. In this presentation, we'll explore how instruction execution works with examples. So to execute a program or an instruction execution, there are mainly three types that need to be achieved first. That is fetching the instruction, decoding the instruction, and execution of the instruction. Now Yash Deshmukh will continue with the presentation.
The first phase of complete instruction execution is the instruction fetch phase. In this phase, the CPU retrieves the instruction from memory and loads it into the instruction register.
So, the second phase of complete instruction execution is the instruction decode phase. In this phase, the CPU decodes the instruction to determine the operation to be performed and the operand involved. The decoded instruction is then passed onto the execution unit for processing. This phase is critical for ensuring that the instruction is executed correctly and efficiently. So the third phase, that is execute, will be explained by Nikhil.
The third and last phase of complete instruction execution is the execution phase. In this phase, the CPU performs the operation specified by the instruction and it stores the result in memory or a register. Now this phase might involve many subphases. It depends on the complexity of the operation that is being performed. The end goal is to ensure that the operation is performed correctly and efficiently.
Let's move towards examples. Steps to perform for adding the data stored in registers R1 and R2. Step number 1. Add R1 and R2. Step number 2. Fetch the instructions. Step number 3. Fetch the first operand, that is, the contents of the memory location pointed by the R1. Step number 4. Perform the addition. And the last step, which is load the result into R2.
I am Vaishnavi Deshmukh, role number 2, and we are going to see control sequence for the addition operation of data stored in registers R1 and R2 in details. The instruction fetch operation is initiated by loading the contents of the PC into MAR and sending a read request to the memory. To perform this task, first of all, the contents of PC have to be brought to internal bus and then it is loaded to MAR. To perform this task, control circuit has to generate PC out signal and MAR in signal. After issuing the read signal, CPU has to wait for some time to get the MFC signal. During that time, PC is updated by 1 through the use of ALU. This is accomplished by setting one of the inputs of the ALU register Y to 0 and the other inputs is available in bus, which is current value of PC. The updated value is moved from register Z back into the PC. The next step is initiated immediately after issuing the memory read request without waiting for completion of memory function. This is possible because this step does not use the memory bus and its execution does not depend on the memory read operation. The next step has been delayed until the MFC is received. Once MFC is received, the word fetch from memory is transferred to IR, that is instruction register. Because it is an instruction, the instruction fetch portion is same for all instructions. In next step, inwards, instruction execution phase takes place. The destination field of IR, which contains the address of register R1, is used to transfer contents of register R1 to register Y. and wait for memory function complete. When the read operation is completed, the memory operand is available in MDR. The result of addition operation is performed. The result of addition operation is transferred from temporary register Z to the destination register R2. The end indicates the end of execution of instruction by generating end signal. This indicates completion of execution of the current instruction and causes a new fetch cycle to be started by going back to step 1. Well, this is all we have for today. Let us now summarize what we discussed about. By understanding how complete instruction execution works, programmers can also identify and resolve potential issues with the code more easily. This makes it an essential skill for everyone working in the field of computer programming. Complete instruction execution is a critical process for ensuring the correct and efficient execution of computer programs. By following the 4 phases outlined in this presentation, programmers can ensure that the programs are optimized for performance and accuracy.